Hello, everyone. Today we're just going to go over the introduction to acceleration solving for all variables worksheet 1. Just review this, and then we will go through and you guys can go ahead and complete this. But anytime you're going through, please start out with your data table. We have the same 4 variables: the initial velocity, the final velocity or final speed, the acceleration, as well as the time. And for each of the different variations, here's each of the different equations. The biggest thing is whichever variable you're solving for, please pick the one that has that variable by itself. So if I'm solving for the acceleration, I would use this first one. If I'm solving for the time, I would use this one. If I'm solving for the final velocity, this equation. And if I'm solving for the initial velocity, that is the last equation. Please take note, please only put the numerical value for your answer. Please do not put any units, as that ends up resulting in a lot of errors, just because it has to be an exact match. And if it even extra spaces can cause an answer to be wrong when it appears to be right. Also, just whenever I'm typing in Google Forms, it's hard to put in meters per second squared. So I typically just write it in as, for any units, m/s/s. That is meters per second squared. And that value will always end up being our acceleration, as that is the only thing we measure in those units. So I'm going to step through 2 problems with you guys, and you guys can work on the remainder. And I have this over here. Okay. Charlotte is driving down the road, reaches a speed of 49 meters per second after accelerating for 6 seconds at a constant rate of 7 meters per second squared. How fast is she originally traveling? A couple things to point out. I have right here, I have the initial speed, or I have a speed. Maybe I don't know if that's the initial, maybe I don't know if that's a final. But I do happen to have that there is a total of 6 seconds. That is my time. I have an acceleration, meters per second squared. That's what I measure acceleration in. And the question asks, how fast is she originally traveling? So if it's originally traveling, that's asking for initial velocity. This speed up here, this ends up being a 49 meters per second, because this was after, speed after. So that means that's our final velocity. This particular one, I want to solve for the initial velocity, which happens to be this equation, VI equals VF minus AT. The initial velocity, I don't know. I just leave that as a variable. The final velocity, 49, minus A times T, which is the 7, and this is 6. If there is no symbol in between 2 letters, that means it is implied that there is multiplication between those. And the nice thing with either the VF or the VI, I can just type that in a calculator just like it is. But 49 minus 7 times 6 equals 7 and meters per second. And the 7 is a value that I want to put into the form. So again, answer for number 1, that happens to be 7. Back to question number 2 then. A car is moving at 10 meters per second, speeds up uniformly to a speed of 30 meters per second in a time of 5 seconds. What is the car's acceleration? Car is moving at 10 meters per second. That is my initial velocity. Meters per second always measures velocity. It goes from this to 30. 30 is my final velocity, and it took 5 seconds. Wanting to know, what is the car's acceleration? If I'm solving for acceleration, that happens to be the very first equation. I'm going to write it out. VF minus VI divided by the time. Acceleration is 30 minus 10 divided by 5. And with this equation, I do recommend make sure that you guys do this subtraction first before dividing, because that can end up leading to a lot of errors. So when I take 30 minus 10, that gives me 20 over 5. And when I take 20 divided by 5, that's going to give me a total of 4. And that's what I want to put into my form for number 2. Okay? And go ahead and work on the remainder of the problems.